Okay, hope everyone's ready for some fun and exciting using Taylor series to do some cool stuff. For example, we can use the Taylor series to find limits of certain functions, including rational functions. So let's look at a specific example here. Let's use a Taylor series to find the following limits. So one important thing to note when you're using the Taylor series to find a limit is, well, this important thing, that where x is going, that gives you the center for the Taylor series. Now, we're not finding Taylor series of everything here. We only need to find the Taylor series of e to the x. Now, you might say, yes, we could do this with L'Hopital's rule, and you are so right, we could. But I don't want to do it with L'Hopital's rule. That is so last year. All right, so let's do this. So e to the x. Well, that's one of them you're supposed to memorize. We know that it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So that tells me that e to the x minus 1, no sense in writing it legibly, e to the x minus 1 is going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial, minus 1. And what is that going to give me? That's just going to give me x plus x squared over 2 factorial plus x cubed over 3 factorial, etc. And finally, e to the x minus 1 over x is 1 over x times e to the x minus 1. Yes, I know my algebra's fancy sometimes, but my point is we can multiply e to the x times our power series. And when we do that, we're going to get 1 plus x over 2 factorial plus x squared over 3 factorial plus, and so the limit as x goes to 0 of e to the x minus 1 over x is equal to the limit as x goes to 0 of 1 plus x over 2 factorial plus x squared over 3 factorial plus which is equal to 1. And you can show that this is true. That's interesting. So, limit is x comes to 0, even x minus 1 over x is equal to limit is x comes to 0, x over 1, 0, which is 1. But it's not always easy, right? I mean, we're not going to always use this when it's, something we could do easily with L'Hopital's rule, but maybe something a little more interesting. Okay, so to be fair, we can't really take the limit. I mean, there's no center. We can't find a center here. So here we have an interesting problem, right? We have x going to infinity. What the heck's the center here? Hint, it's not infinity. Okay, so what do we do? So this one's kind of a special one. What to do? Well, let's do a change of variables. Let's let t equal 1 over x, right? So then x is 1 over t. And so our function f of x equals x sine 1 over x becomes a function f of t being 1 over t sine of t, and our limit as t goes to infinity becomes, I'm sorry, our limit as x goes to infinity becomes the limit as t goes to 0 from the right. We know it's from the right because if x going to infinity, we know x is positive. Okay, so let's do it. All right, so we're going to let t equal 1 over x, and so we're going to be looking at the limit as t goes to 0 from the right of 1 over t sine of t. All right, so now we're back in business. And again, this is going to give us the center is going to equal 0. Okay, so the center is 0. And what do we need to take the Taylor series of? Well, there's only one function to take the Taylor series of, so we need the Taylor series, or equivalently the Maclaurin series. Okay, so we know that one. That's one of them we were supposed to memorize. We know that sine of t is going to be t minus t cubed over 3 factorial plus t to the 5th over 5 factorial, da 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 da. So 1 over t sine of t is going to be 1 over t times that. Which is going to be 1 minus t squared 3 factorial plus t to the 4th over 4 factorial, da 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 da. And what happens when we take the limit as t goes to 0 from the right of this? So we're looking at the limit as t goes to 0 from the right of 1 minus t squared over 3 factorial plus t to the 4th over 4 factorial. Oops. Oh, Sugarfoot. That's what I get for not putting my parentheses to begin with. And I get 1. And we've done this problem before using the squeeze theorem, so we kind of know what yeah. I know this. Alrighty. And that's it. So the idea is that the limit as t goes to 0 plus of 1 over t sine t. The limit of the thing we're finding. The limit as x goes to infinity of x sine 1 over x is equal to the limit of t goes to 0 plus 1 over t sine t is equal to 1. I don't know what the sense is for. There's an exercise here. I'm going to let you play with that. And we'll talk about integrating power series using Taylor series. I get concerned that if I'm with you writing the answers, that like maybe you're not going to be playing the game fairly and doing these. So I'll tell you that the answer is 0, but you have to do the work, and well, we'll talk about it in class. Integration approximation using Taylor series. So we want to approximate the integral from 0 to 1 sine of x over x with an error no greater than 10 to the negative 5th. This is by no means a simple task. And in fact, I think I might make that a separate video. So I think I'm going to stop this one right here. And stay safe and see you in the next